Waalaikumsalam, sir.
Okay, saya start recording. Okay.
Okay, sir.
All of you has time to look at the slides yesterday? Ada tak? Tengok slides. Ada bahagian yang tak faham? Saya kalau boleh nak selesaikan the lecture today, slides, then after that kita ada what you call it, clarification ke apa ke, then I can go through and also I can what you call it, bagi some exercise or assignments untuk you buat lah, right? So that you have a proper, a more deeper understanding, right? Of what we cover this week. Okay. So kalau tak ada, I will continue with the lecture where we left off yesterday. Okay.
Okay, sir.
Okay, saya pasang slide jap. Okay, I'm going to share the slides. Okay, anybody, everybody can see the slides? Voltage divider rule, VDR.
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
This
sir.
is where we left off yesterday. So we have actually 55 slides. So we are at slide number 43. So we can finish today. And next week we can what call it, discuss some of the questions with regards to the theory that we learned this week, and also we go into the next chapter, which is resistive network, where we are going to use the theory that we have that we learned this week, how to solve the problems in circuits which consist of pure resistance instead of basically that no inductance or no capacitor, just purely resistive network. Okay, so the next rule or law is the voltage divider rule. Voltage divider rule is useful in determining the voltage drop across resistors within a series circuits. So let's say that we have a circuit in VS. We have three resistors, VS as the battery. Then we have R1, R2, and R3. Okay, so the voltage across each resistor can be calculated using the voltage divider rule. For example, if you want to find the voltage across R1, therefore V1 is equal to R1 over R equivalent times the VS, the source, the voltage source. So that is the formula. So in general, the formula is that Vx is equal to Rx over R equivalent times Vs. Okay. So the R equivalent, this one is that for this series network is basically R1 plus R2 plus R3. Okay. So Vx for this particular example is equal to Rx over R1 plus R2 plus R3 times Vs. Okay. So Rx, R equivalent here, we learned this yesterday. For the series resistor is R equivalent is equal to R1 plus R2 plus R3 plus Rn for n number of resistors in series. Okay. Example, determine the voltage across R2 and R3 for these circuits. Okay. You have R1 basically is 10 ohm, R2 is 20 ohm, R3 is 30 ohm, and a voltage of 60. So the formula is that if you want to find the voltage across R2, so therefore V2 is equal to R2 divided by R equivalent times Vs. What is R equivalent for these circuits? Is equal to R1 plus R2 plus R3. So 10 plus 20 plus 30 equal to 60 ohms. So therefore, V2 is equal to R2, which is 20 ohms, divided by R equivalent, which is 60 ohms times 60. So V2 is equal to 20 volts. Okay, that is the solution for V2. Okay, so basically that R equivalent is the total R1 plus R2 plus R3 because this is in series. And the value of R2 is 20 ohm. Okay? So R2 divided by R equivalent times Vs, Vs is 60, get 20 volts. For the voltage across R3, so V3 is equal to R3 divided by R equivalent times Vs. So what is R3? Is 30 divided by R equivalent is 60 times 60. So therefore, R3 is equal to 30 volts. What is the voltage across R1? Anyone can guess? Or anyone can calculate?
10, sir.
10 volt.
That's correct. So basically that you get the hang of it already. Right? This is another example. Determine the unknown voltage V3. From the schematic diagram given, the given data is R1 is 10 ohm, R2 is 6 ohm, R3 is 8 ohm, and Vs is 3 volts. And you need to find the voltage across the R3 here, V3. So from here, basically that we use the KVL, the Kirchhoff voltage law, which is the summation of a voltage in a loop is equal to 0. For in this case, since the plus sign of the voltage source is on the right, on the left, so therefore we assume the flow, the current flow is counterclockwise because from the Vs. So the current flow out from the positive sign of the source. Okay, we have Vs minus V1 minus V2 minus V3 equal to 0. Okay, so using the voltage divider rules, that V3 is equal to Vs times R3 over R equivalent. So R equivalent here is R1 plus R2 plus R3. So Vs is 3 volts, R3 is 8 ohms, divided by 10 plus 6 plus 8 equal to 1 volts. Right? Any question for this? Clear?
Yes, sir.
Okay.
Mhm.
If we have a voltage divider rule, then we have a counterpart rule, which is current divider rule. Voltage divider rule is for series resistors. Therefore, current divider rule is for parallel resistors. Okay. So the formula, the basic formula is as Ix is equal to R equivalent divided by Rx times Is. You see this formula is actually reverse of the
Current.
voltage divider rule, right?
Voltage divider.
Okay. Voltage divider rule was Rx over R equivalent times Vs, whereas current divider rule is R equivalent divided by Rx times Is. Okay. So Ix is the current flow through any particular parallel branches. Rx is the resistance of the branch through which the current is to be determined. R equivalent is the total resistance of the parallel branch. Is is the circuit applied current. So, example, find each of the branch currents in the figure shown below. So you have three resistors connected in parallel, and you have the total current of 12 milliamps flowing through these three resistors. And these three resistors basically is connected in parallel. So what is IR1? What is the formula?
1 over
IR1 is equal to R equivalent divided by R1 times IS. So from that formula, you need to find the R equivalent, right?
Yes.
What is the R equivalent? Formula from yesterday. 1 over R equivalent equal to 1 over R1 plus 1 over R2 plus 1 over R3, right?
Yes.
So this is the R equivalent. This is how you calculate the R equivalent. Okay? So 1 over R equivalent is equal to 1 over R1 plus 1 over R2 plus 1 over R3 equal to 1 over 3K plus 1 over 8K plus 1 over 24K is equal to 1 over 2K. So therefore, R equivalent is equal to 2 kilo ohms. Okay. So now we already have the R equivalent. Therefore, we can solve this problem using the formula of Ix equal to R equivalent divided by Rx times Is. Therefore, this is the solutions. For IR1 is actually R equivalent over R1 times I or Ix. 2 kilo ohm, which is R equivalent that we calculated just now, divided by 3 kilo ohms times 12 milliamps. Okay, so equal to 8 milliamps. So IR2 is equal to R divided by R2 times I. So 2 kilo ohms divided by 8 kilo ohms times 12 milliamps equal to 3 milliamps. So IR3, R equivalent divided by R3 times I is equal to 2 kilo ohms divided by 24 kilo ohms times 12 milliamps. So equal to 1 milliamps. So if you want to check whether your answer is correct or not, so you go back to the Kirchhoff current law. What does it say? Kirchhoff current law says that the summation of a current flowing into a node is equal to the summation of the current flowing out of the node. So we have 12 milliamps flowing into the node, okay? And we have three currents flowing out, IR1, IR2, and IR3. So therefore, the summation of the current going out from the node should be equal to 12 milliamps. So 8 plus 3 plus 1, so equal to 12 milliamps. So therefore, your answer is correct. Okay. Another example. Determine the unknown current I1. Okay. You have Is, which is given as 4 amps. you have R1 of 10 ohms, R2 2 ohms, R3 20 ohms. So from here, we need to find the I1. So I1 is actually equal to IS times R equivalent divided by what? R1. Okay. So that formula actually 1 over R1, and those actually is actually what? R equivalent over R1. Right? So we plug in the figure into the formula. So you got 0.6154 amps. Anybody got that? So you should check this later. So in general, this is actually for the particular case of two parallel resistors. If you have two parallel resistors, therefore the R equivalent is R1 times R2 divided by R1 plus R2. This only applies for two parallel resistors. And the current passing through R1 and R2 are given by that formula. I1 is actually equal to R1 equal to R2 over R1 plus R2 times I. And I2 is equal to R1 over R1 plus R2 times I. This formula only works for two parallel resistors. You cannot use this formula for resistors parallel more than two. Okay? Remember that.
Okay.
So this is actually when you have the circuits that when you want to measure the current flowing through the circuits and whatnot, we have a few measurement devices. The first one is ohmmeter. Okay, the ohmmeter is a device that you use to measure the resistance of a device. Okay.
Okay, sir.
So how do you do that? Basically, you connect across a circuit element, then you read the value display on the ohmmeter. The resistance of an element can be measured only when the element is disconnected from any other circuit. So basically that you have to take out the element from the circuit and measure. You cannot measure resistance directly on the board, on the circuit board. You have to take it out, the component, and measure. Okay?
Yes, sir.
Ammeter. Another device is called ammeter. Ammeter is a device that when connected in series with a circuit element can measure the current flowing through the element. So this is to measure current. So the ammeter must be placed in series with the element whose circuit is to be measured. So ammeter should not restrict the flow of the current, or else it will not be measuring the true current flowing in the circuit. So an ideal ammeter has zero internal resistance. So basically that for current, if you want to measure, you have to break out the circuits and put in your ammeter device in series with the element. Just like this, okay? Let's say you have a circuit, two resistors, R1 and R2, and you have a voltage source, Vs. So you want to measure what is the current flowing in this circuit. But therefore, what you need to do is that you break out the circuit and you put the ammeter in the circuit in series with the resistors. Okay, so therefore this ammeter will give you the value, the current flowing in the circuits here. So it will give you how many amps. I is how many amps. This is how you connect the ammeter in a circuit. Okay.
Okay, sir.
Another measurement device is a voltmeter. It's a device that can measure the voltage across a circuit elements. Okay. The voltmeter must be placed in parallel with the element whose voltage it is measuring. So if emitter you put in series and the internal resistance of the emitter is 0, therefore for the voltmeter is actually opposite. So instead of you place in series, you place in parallel with the element that you want to measure. And the ideal voltmeter has an infinitely large internal resistance so that you don't load the element, so that there is no current flowing through the voltmeter. So the voltmeter should draw no current away from the element whose voltage it is measuring, or else it will not give a true measurement of the voltage across the element. So therefore, the ideal voltmeter has infinite internal resistance. So this is how you connect the voltmeter in a circuit. Same circuit just now. You have Vs, R1, and R2, and you want to measure the voltage across R2. So what you do is that you take the voltmeter, you connect in parallel with R2. And therefore, since the voltmeter, the ideal voltmeter, the resistance is very large, therefore there is no current flowing here. So only the current flowing in R2. So the voltage is that basically the current times R2. If this voltage, if this voltmeter is not an ideal voltmeter, so you will have current flowing here. So what happened is that with a current divider, basically the current flowing in R2 is not I anymore. It's basically less than I. So the value across, the voltage across R2 will be lesser. So it's not the true measurement of the current flowing in the circuits if there is no connection of this voltmeter. Okay, so that's why your voltmeter must have an internal resistance with a very large resistance or infinite resistance. So there is no current flowing here. Okay, so that is actually what we have for this week. Any question? Any question?
No question, sir.
Okay.
Yes, sir.
I have question, sir.
Any question for you since from yesterday lecture? Any part that you need me to go through?
No, sir.
No. So you are happy with class far?
Yes, sir.
No confusion so far. Tak ada apa ni, kalau tak ada soalan apa semua, then we can stop the lecture today. If you have problem, if you have question, you can ask me through the email. You can ask me through the WhatsApp, and you can ask me through the chat in the MS Team. You have so many ways to contact me, and utilize that those channels. Any question? Very fast today.
No, sir.
No, sir.
If there is no question, what I'm going to do is maybe tonight I will send you some of the practice or questions, examples of problems you to your own. Okay.
Okay, sir. Okay, sir.
Practice assignment, sir.
I give you actually, I call it assignment number 1. So basically, you,
Not clear, sir.
so I will try to prepare tonight some of them, some of the questions. Okay.
Yes, sir.
Okay, sir.
So any question today?
When did you
And the
date,
class
sir?
today for this week. And next week we'll go into the resistive network. That one will take 3 weeks lecture. It'll be a lot of topics to cover, and you need
Oh, God.
attention next week. Okay,
Okay, sir.
Okay,
thank
sir.
you.
Okay,
Try
sir.
to stop recording today. Okay, thank you.
Okay, sir.
Thank you, sir.